So what is the derivative? If you have probably taken a class in calculus or differential equations, you have probably come across what a derivative is and how to calculate it. But what exactly is it, right? So, according to definition, it is the rate of change of a function with respect to a variable. But if you aren't so fluent with math terminology, you may not really understand what it means. So, in this video, I'll be going to explain what this really means. So, a function usually defined as fx is usually when your input is something like this. Easy way to visualize it. Where you input something to fx, x, and outcomes y. So let's say a function, if f of x equal to 2x, right? Now when you get x, when you input it to 2x, outcomes y, right? And if x is 1, y equals 2. X is 2, y equals 4, right? And then a variable in this case is usually denoted as x or y, or basically any other kind of symbol or letters that you can use, and usually represent something that constantly changing, right? Something that constantly changing. You can input any number inside there, and it will work, right? Now that we understood what these functions and variables are, we're going to go over derivative, right? Now, we understand that the rate of change, if you have taken at least some class in algebra, you should know that the graph of x and y, or in this case fx, also is the same thing, where y equals to fx. Let's say the graph of x squared is the graph of x squared. Now, you know, if you want to take the tangent of a graph, we usually take rise over run. Rise over run. Rise over run. And how do we calculate the rise over run? Okay, let's say in this case, this part of the graph let me redraw the graph. Let's say you wanted to take this point, which is 1, and this point, which is 2, on the x-axis, and here is 2 on the y-axis. Let me draw it a bit more clearer. Right, and 4 on the y-axis. Rise over 1, since it increased by 2, it will be 4 minus 2 and 2 minus 1, right? Or you can, I mean, let's put this way, y2 minus y1 divided by x2 and x1 equals to 4 minus 2 divided by 2 minus 1 equals 2 minus divided by 1 equals to 2, and this will be your slope, right? Now, shouldn't this be sufficient? Well, look at this. When we calculate the slope, we calculate the slope from this part to this part, And you notice how there's still a bit of line here. A perfect tangent should be exactly touching a line at only one point. Right? So how do we calculate that? Now, that is where we use the concept of derivatives. Right? So, if you want to use the formal understanding of a derivative, I suggest you going over what a limit is. But basically, it's a limit, or usually denoted a limit, is when you slowly approach some point in a graph, right? So, in the definition of a derivative, it's listed at the limit as h approaches 0, f of x plus h minus f of x divided by h. Now, before you click away this video, seeing at this complex equation, it's not really that complex. Let me explain. Now, given we have the same xy graph again, right? Now, we know the same points from before. 1. Okay, let's not call it 1. Let's call this x, and this place x plus h, where this distance is h, right? And here, if f of x, and here, my bad, and here, f of x plus h, right? Now, can you imagine at this point, as h slowly becomes to 0, it goes from here, all goes the way to here. But it's not totally 0 where it's back to this point, but very, very close to this point, maybe around here. Then you see, you will get a very accurate tangent line, right? Now, let's say, since this equation of this curve is y equals x squared, or I prefer to use the term f of x equals x squared. Now, using this definition of the derivative, you can find the derivative limit h approach 0 of f of x plus h. If you x plus h into here, you get x plus h squared minus f of x equals x squared, right? And we divide by h. Now, this will equal to the limit as h approaches 0. We can just expand, right? So you get x squared plus 2hx plus h squared minus x squared, right? Divided by h. Now, we can simplify. Remove the x squared because minus of each other. Limit as h approaches 0, 2hx plus h squared over h. We can further simplify, right? We got h as a common factor. Lim as h approaches 0 for h, 2x plus h divided by h. Which way we can cancel out this h. Lim as h approaches 0, 2x plus h. Now, as h approaches 0, maybe we want to substitute h as 0, so equals 2x plus 0 equals 2x. And there we go. We have the derivative of the function, right? So, usually, let's test this, alright? So, if we have the derivative to x, and this point is, let's say, 1. Let me use a different color. 1. if we input x equals to 1, right, the derivative, the tangent at that point, basically, is 2, 1 equals to 2. That means the slope at this point, now pardon my drawing, the slope at this point, the exact slope, where it only touches x equals 1, at that point, this slope, slope is equal to 2. What if you wanted to know at another point? Let's say this point is 4, right? 4. So x equals 4, then the slope at the point, 2, 4, equals to 8. That means the slope at this point, pardon my drawing again, the slope at this point, slope equals to 8. Right. Now that we have formally understood the definition of the derivative, I will be going to explain the different rules that we can use to calculate derivatives in the future. Because, I mean, obviously, imagine using this definition to calculate something like the derivative of function equal to, let's say, square root of x plus x to the power of 10 divided by x plus 15x. It will be pretty complex to calculate this function using this definition, right? So in the future, we will be going to discuss on the different rules we can use to calculate derivatives.